Alright everybody, we're on chapter 7.4, which is how to graph an ellipse. An ellipse is part of our conic sections. And so I want you to hit the pause button and write down these two types of ellipse equations. There are two general forms of the ellipse, which is x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. The other one is very, very subtly different. It's x minus h quantity squared, same as the last, over b squared this time, plus y minus k quantity squared over a squared equals 1. A couple things I want you guys to know about the ellipse before we even get started. And I'm going to type these out, that way you don't have to suffer through my handwriting. The letter A is always an indicator of what we call the major axis. And let's just go ahead and put this in regular terms. That's the long axis. Major axis means long. B would be the minor axis. Now, using some deductive reasoning, you might have been able to figure out this is the shorter axis. And then the center of an ellipse is always going to be opposite of h, opposite of k. Similar to the parabola, remember how it was opposite of h, comma k? Same thing is going on here, but remember, we covered this in class. Every time there's a shift going on inside any type of grouping symbol, remember, it's always opposite your intuition. The graphical shift appears opposite your intuition. So we will graph several ellipses in this video, and so you will see what I'm talking about. And the last thing about the ellipse is that an ellipse is always equal to 1. Always equal to 1. So please make sure you copy this down. There are a lot of factoids about the ellipses that you're going to need to remember for this lesson. So let's go ahead and take a look at what these ellipses are going to look like. If I had to draw a rough sketch of the yellow ellipse here, where a squared, the minor axis, is underneath the x, what that means is that my ellipse is going to be longer than it is tall, because my major axis is longer and my major axis is under x. So therefore, it's going to be stretched horizontally. On the second ellipse, notice how my major axis is underneath y? That would make sense then if the ellipse was taller than it was wide. So hopefully you guys were able to copy that down. Let's go and get some more definitions. I'm going to pause real quick. Alright, the foci of an ellipse is defined as two fixed points inside the ellipse, such that the distance between them remains constant. Hello, hang on for a second. Sorry about that. That was Teacher Adam just texted me talking about how Teacher Joseph just ate all of his candy. Alright, anyway, the way to find the focal distance of an ellipse is we use this formula, and I like to just simply call this what we call CAB formula opposite. So c squared equals a squared minus b squared. So your focal distance, which is what this c is the difference between your major and minor axis. So just think of it as CAB formula opposite. When we study the hyperbola in the next lesson, you'll see why I call it that. But just imagine this, since we are adding in an ellipse, we're going to be subtracting to find the focal distances. So go ahead and take a second and copy that down. I'm going to go ahead and erase all this and pause real quick. Alright, our homework tonight, should we choose to accept it, is to find the coordinates of the center, foci, and the lengths of the major and minor axes. So let's take a look at an example here. Odd. If I give you an example of, say, x squared over 25 plus y squared over 9 equals 1, first thing we got to figure out is this thing an ellipse? Of course it is. We've got two squared terms being added, and they equal 1, and they're both over some kind of perfect square looking thing. And actually, it's not always going to be a perfect square, but for purposes of this homework, it probably will be. First thing I want you guys to do is I want you guys to identify all the parts, so a and b. Well, a, remember, this 25 here is a squared, so that means that a is going to be 5. This 9 here is b squared, which means that b is automatically going to be 3. From here, I want you guys to go and find c. Now remember, to find c, which is my focal distance, I'm going to use CAB formula opposite, which is c squared equals a squared minus b squared. Well, it's a good thing that a squared and b squared are given to us, this 25 and 9, so c squared is going to equal 25 minus 9. Remember, I just pulled a squared here, b squared here. All right? So 25 minus 9 is 16, and that equals c squared. Luckily, it's a perfect square, so that means that c equals 4. From here, I'm going to go ahead and identify the center of the ellipse, which is going to be 0, 0. Notice there is no shiftage happening within the inside of x and y. And from there, I'm going to go ahead and find my focal coordinates. Focal coordinates. Now, remember, the foci is always lying along the major axis. The major axis is a squared. It's the bigger number in this case. The bigger number in this case is 25, which means that my ellipse is going to look kind of like this, because the bigger number is underneath x squared. So hopefully that makes sense to you. Which means that my focal coordinates are going to be along this x-axis, which means that my x-coordinate is the thing that gets affected by this focal distance here. So 0 plus or minus 4 is my focal coordinate, comma 0. To put this in more concrete terms, my focal coordinates here would be 4, comma 0 and negative 4, comma 0. So let's go and graph this thing. So I've got my graph, I've got my center here at 0, 0. And let's go ahead, and I know we haven't found the lengths of the major and minor axes yet, but I want to show you guys how to graph this before we get anywhere. A squared is 25, B squared is 9. That means that A is 5. If A is 5, that means I'm going to move out 5 spaces to the right and left, because again, my major axis is underneath X. So I'm going to go out 1, 2, 3, 4, 5. I'm going to draw a point. From the center, I'm going to go back 5. 1, 2, 3, 4, and 5. My minor axis was 9, which means that I'm going to move up 3 in each direction. So 1, 2, 3, and then down 1, 2, 3. From here, I'm going to go and connect the dots, and this is looking very yellow, so I'm going to switch over to ketchup. I'm going to go ahead and draw my ellipse. All right, notice how it is a little bit wider than it is tall. And now it's time for my foci. Let's go ahead and change colors for that. Let's go to blue. And so my focal coordinates are 4, 0, negative 4, 0. And for foci, I like to draw an open circle. Okay? Now, let's go ahead and finish up this problem with finding the lengths of the major and minor axes. The length of the major and minor axes is pretty simple. What you do is you take A and you double it. So the major axis is going to be 10 units. The minor axis is going to be 6 units. And you are done. So let's just summarize everything that we've done so far, because this can be a little bit cumbersome. We found A and B. The reason why we found A and B was to find C, C being the focal distance of my foci from the center of the ellipse. I mapped out the center, I mapped out my focal coordinates, I graphed it, and I found my major and minor axes. I know it's a lot to take in. We're going to do about 200 or 300 more of these. It's just like learning a brand new concept in martial arts. Sometimes it just takes doing 1,000 of them before you become used to it. Before your arms become used to striking the wooden dummy. X plus 8 quantity squared over 144 plus y minus 2 quantity squared over 81 equals 1. Okay. I'm going to jump around a little bit on the order because I want you guys to be able to free flow and think kind of like Tai Chi. So I'm going to go ahead and identify the center before I do anything. The center is going to be negative 8, positive 2. And so I'm going to go ahead and identify A and B. Well, A is 12. I took the square root of the larger denominator. B is going to be 9. And C, well, that's going to be found using my CAB formula reversed. So C squared equals A squared minus B squared. After doing the computation, you're going to get c squared equals 144 minus 81. C squared equals 63. Therefore, C equals 3 rad 7. So, we have a center. We have A, B, and C. So I need my focal coordinates. Now, remember, this ellipse is going to be wider than it is long, and that is known because the larger denominator is underneath the x term. So let's go back to our center. This is negative 8, comma 2. The reason why I left myself space between this negative 8 and the comma is because my foci are going to be rested along the major axis, which means this is really negative 8 plus or minus 3 rad 7. And again, to give you guys something a little more concrete, it's negative 8 plus 3 rad 7, comma 2, and then negative 8 minus 3 rad 7, comma 2. So let's go ahead and get ready to graph this thing. First of all, it's going to be an off graph because our center, remember, is at negative 8, comma 2. So I'm going to have to draw a very, very large graph for this thing. So I'm actually in, you know what, I'm going to go and scale everything by 2. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I had to scale this by 2's. That way I can fit my center on there. So negative 8, comma 2 is going to be negative 2, 4, 6, 8 up 2. So this is the center of my ellipse. Now from here I'm going to move out 12 times. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. And now I'm going to move up 9. So that is 2, 4, 6, 8, and then half. And then 2, 4, 6, 8, and then half again. Now I'm going to go ahead and draw my ellipse. Okay. So now what I'm going to do is I'm going to go and guesstimate negative 8 plus 3 rad 7. That's just negative 8 plus 3 times rad 7. Well, rad 7 is approximately in between 4 and 9, leaning more towards 9. So I'd say 2.6. 2.6 times 3 is going to be 6 something or other. So I'll move 2, 4, 6, and a little bit. Oops, change colors. I'll move 2, 4, 6 and a little bit. Draw my foci 1 here. 2, 4, 6 and a little bit. My second foci goes here. Now the last thing we need is the lengths of the major and minor axes, and we can actually find these out before even graphing this thing. So I'll say the major axis is going to be 24. The minor axis is going to be 18. Now I got those by doubling the lengths of A and B. Multiplied them both by 2. Again, lot to do, but don't worry, it gets easier. It definitely gets easier. So let's do another one because we like ellipses. Ellipses. Yeah. Planets orbit in an elliptical fashion. The elliptical is a great machine to get in shape if you're working out at 24-hour fitness. Alright, so let's go ahead and do number 3 here. Number 3, there's going to be an extra layer of stuff to do before you get to where you need to be. Remember, all ellipses must equal 1. So the first thing I'm going to do is I'm going to divide everything by 81 because the ellipse has to equal 1. So 1 is going to equal 9 over 81 is y squared over 9. 27 over 81 is x squared over 3. So now we've got our equation of the ellipse. Let's do what we've always done. We're going to find the center. The center's at 0, 0. A is going to be the square root of 3. So let's go ahead and just guesstimate that. That's about 1.7. B is going to be 3. And C, well, C is going to be c squared. Let me scroll down here. C squared equals A squared minus B squared. Now this time A squared is 9, because remember, A is the major axis, which is always the bigger number, so it's 9 minus 3. Please do not do 3 minus 9. So C squared is going to equal 6, so C equals the square root of 6, which is approximately, let's see, in between 4 and 9, leaning a little more towards here, so let's say 2.6. So let's say our focal coordinates are going to be 0, comma. Now, before we figure out the focal coordinates, let's draw a rough sketch of this ellipse. Remember, 9 is the major axis because it's the bigger numbers, and it's underneath y, so it's going to look a little more like that. So my focal coordinates are going to be 0, 0, comma 0, plus or minus rad 6. Now, I tacked the plus or minus rad 6 onto the y because remember, the foci is always along the major axis, and in this case, the major axis is y. Okay, so my center's at 0, 0. I'm going to move out 1.7, so that's about right here, and about right here. B is 3, so that's going to move up 1, 2, 3, down 1, 2, 3. I'm going to switch colors here to draw my ellipse. Small ellipse, but that's okay. Now my focal coordinates are going to be 0 plus or minus rad 6. Rad 6 is about 2.6, so 1, 2, and a little bit. 1, 2, and a little bit. And there we have it. We just need to figure out the lengths of the major and minor axes. So the major axis in this case is 6, because remember, the major axis is always the bigger number. And then the minor axis is 2 times rad 3 is 2 rad 3, and you are done. You've done everything you can for the ellipse. Let me clean this up for a little bit, and we'll go on to something a little more difficult. Well, how can they make this more difficult? Well, what they can do is give you a problem like number 4, which looks like this. X squared plus 4x plus 5y squared plus, sorry, not plus, minus 70y plus 209 equals 0. And they'll tell you to find the coordinates of the center, foci, lengths of the major, minor axis, blah, blah, blah. Well, for those of you who have seen this problem and are kind of waiting around in anticipation, I'll basically give you the climax of this movie. You need to use completing the square to write this whole thing in its conical form. So what I'm going to do is I'm going to separate this out. X squared plus 4x. Leave yourself some space. I'm going to do a couple things at the same time here with this side here, the y side. I'm going to factor out a y, rather a 5, leaving me with y squared minus 14y. I'm going to leave myself some space again, equals negative 209. So what I've done is I've separated out the x's and y's. I've left myself some space here with the x's, factored out a 5, and subtracted 209 all at the same time. Well, here's what I'm going to do. I need to do completing the square twice. So I'm going to add the box to both x and y. I'm going to add the box to the other side. Now, those of you who remember from the last chapter, the second box here has a little bit of a caveat to it, and that is because it's being multiplied by 5. So the second box is going to get multiplied by 5 before we add it in. So let's figure out what goes inside the boxes. That would be 2. This would be negative 7. I've got a 2 here and a negative 7. So let's go ahead and simplify the easy sides. That is going to be x plus 2 quantity squared plus 5 parentheses y minus 7 quantity squared equals. Well, the hard side, I've got 4 here. I've got 35. 35 times 5 here. After all these computations are done, I'm going to get a grand sum of 40. Now, remember, an ellipse always has to equal 1, so I'm going to go ahead and divide by 40 everywhere. So my final ellipse is going to be x plus 2 squared over 40 plus y minus 7 squared over 8, because 5 into 40 leaves me with 8 on the bottom. And now I have my equation of the ellipse, so now I am ready to do exactly what we've been doing for the last 3 examples. and that is to find the center, which is -2, 7. My A is going to be 2 rad 10, which is the square root of 40. The square root of 40 is 2 rad 10. B is going to be 2 rad 2, which is the square root of 8. And C, well, C squared is going to be 40 plus 8, 40 minus 8. So that is C squared equals 32. If I take the square root of that, I get 16 and 2. So my C value is 4 rad 2. So that means that my focal coordinates are going to be, let's see here, before we find the focal coordinates, what type of ellipse is this? This is a sideways ellipse because my bigger number is underneath my x values. So it's going to be the x coordinate being impacted by focal coordinates. That is 2 rad 10 plus or minus 4 rad 2. Kind of complicated, but not really. Comma 7. Sorry, not 2 rad 10. -2. Get rid of that. -2 plus or minus 4 rad 2, comma 7. Okay, I'm going to go ahead and move this completing the square business out of the way because it's getting in the way. A couple things right off the bat here. The square root of 40 is about 6.4, right? Because it's in between 36 and 49. It leans closer to 36. The square root of 8 is in between 4 and 9. It leans closer to 9, so I would say it's about 2.8, 2.9. So let's go ahead and graph this out here. My center is at -2, so I'm going to be a little off the scale here. So I'm going to go ahead and scale everything by 2 this time. So -2, 2, 4, 6, 7 right here. So let's go out 6.4 spaces to the right and left. So 2, 4, 6, and a little bit more. 2, 4, 6, and a little bit more. I'm going to move up 2.8 spaces, so 2 and a little bit, 2 and a little bit. Funny, when I scale it by 2s, the ellipse becomes that much smaller. C is -2 plus or minus 4 rad 2, so that's going to be a little bit more in. So -2 plus 4 rad 2, that's going to be 4 times 1.7, so that's about 4 point, a little bit more. So 2, 4, and a little bit more. 2, 4, and a little bit more. And then the major and minor axes, last little bit. Major axis is going to be 2 rad 10 times 2, so that's 4 rad 10. The minor axis is going to be 4 rad 2. I believe I've sufficiently melted your brain with this, but we will do plenty of examples in class. See ya.